All right. So today I'll be talking about Terraform. I'll be going over some pretty basic Terraform stuff, and then we'll go over how we use Terraform to deploy our competitions. And yeah, my name is Jason. In like April of like mid-March of last year, I was like, I want to do a CCDC minicomp to practice for nationals, and I spent like 3 weeks learning Terraform, and it was a wonderful time. And now I've lost many days to Terraform and making it better. So yeah. Bro. So what is Terraform? Terraform is an infrastructure as code solution, which means that you define resources like cloud, like you define like networks, and you define servers, and you define firewall rules and stuff as code. And then you run the code, and it provisions all of those resources. Other infrastructure as code solutions include CloudFormation, which is specific to AWS. Then Azure has Resource Manager, and GCP has Deployment Manager. But Terraform isn't specific to one cloud provider, which makes it really cool because it's extensible, and you don't have to use a specific provider to write Terraform. We actually use Terraform to deploy Openstack, and we use Terraform within Openstack to use it, which is kind of cool. So it works really quick. On our side of the equation, we write Terraform, and then we will use a specific Terraform provider, in our case OpenStack, to define all of our resources, and then it kind of just goes through and makes things work. So yeah, it's pretty cool. So Terraform has over 1,700 provider modules, which means that pretty much any like cloud service provider that you have, you can write Terraform for it, which is awesome. There's a bunch of verified ones. There's some of the big ones. OpenStack is one of the 1,700 provider modules, and it just makes everything really easy. So how does it work on the more in-depth level? You start by writing Terraform, and you write out your configurations for all the resources, and then the next step after you've written out your plan is you'll run the Terraform with like and then you'll approve the changes that Terraform is going to make, and then it will actually run on the box and create all those resources or destroy all those resources. So the specific commands, well, this is just you write in VS Code, but then here you would run like Terraform plan if you wanted to, or you would run Terraform apply, and then once you run Terraform apply, unless you specify a auto approve flag, you have to approve it by reading over the plan, and then boom, changes get made. So let's go over some pretty simple stuff with Terraform about how we define resources and how we use them, and also some stuff about providers. So everything in Terraform is probably going to be a resource block at one point or another. So the general format for a resource block is you type resource, which indicates that you want to be creating a new thing, and then you do the type of resource. So within the OpenStack API, we have OpenStack compute instance v2. There's also flavor, like compute flavors. You can have images, you have networks, security groups, identity groups, projects. Pretty much everything that you can do through the GUI, you can do through Terraform, and you can do it a lot faster. So then once you define the type of resource, you give it a name, and then you define any specific attributes inside of the block. So right here we have an example of a test server being built, and so we give it a name, test server 1, and then we give it a flavor, and a flavor specifies a couple of key parts of information, namely how much RAM, how many CPUs, and the disk size to give the instance. And we have on the stack, we have a variety of different flavors that are specified for different types of images. Like you give Windows more, more RAM and more CPUs because it's just more intensive. And you'll give like a cloud Linux box a lot less stuff because it doesn't need it. So this is kind of like how you can optimize some of your stack resources. Then we specify some security groups, where security group is a networking, like a firewall rules. So right now we're just going to give it default, which allows it to ping out and hit the internet. And then we specify some very specific stuff to the instance, which is just like the volume. So all this block device stuff right here just defines information in the volume. So we give it the actual image file that we're going to use. So when this gets created, we're just going to have a Linux desktop. We give it a volume size. We always specify delete on termination so that we can keep our volumes clean. And then, then over here we define the network that we're going to put it on. In this case, we're throwing it on the external network, which we'll get to later. Then we also specify an IP address. And then we can use Cloud Init to configure the box on boot to make it easier to run Ansible. And this one block of resource, like this one block, is how we would find one test server or one server. And we'll actually run this Terraform in a bit. So this is a resource block. Any questions? No questions yet. Cool. Then the other cool thing is if we want to reference a resource block that was already made, and instead of remaking it, we use data blocks. It's pretty much the same thing, except we only specify, we use data to specify that we want to reference a piece of information. Then we give it the same like resource name, and we give it the name the name up here is how we will reference it locally, and this is the name of the actual thing like on the stack. So we talked about flavors on this slide. Then this is how we would reference that flavor within our Terraform file. So that way we can use the data.openstack compute flavor v2 flavor medium, and then reference it through the ID. So this is how we have local resources available, but not create them. So as I just said, resource blocks are used for when we want to make something new, and we use data blocks for referencing something that's already been made. And sometimes you don't use either, and it's weird, and you just kind of have to learn. But we'll go over that later too. So variables are also a thing in Terraform. The way that it works is you use the variable keyword, you give it a variable name, you give it a description, and you give it a type. Types are usually strings, booleans, ints. You also have maps. And so in the left, we have the variable definition, and then in the right, we have our variable declaration. And we can use variables to clean up code and make things really pretty. So moving on, when we want to actually do something with the Terraform, we have to have a provider basically tell it what API we're going to use, what type of cloud compute are we using on the back end. And right now we're using Openstack. So we specify the source and the version. And then within our Terraform file, we'll have a provider block where we give it a project name, which is reference to the tenant name attribute. We give it a authentication URL, which is just our OpenStack API endpoint. And we give it our username and a password. And for security's sake, we generally put the username and the password in another file that doesn't get pushed to our GitLab, so that way we're not leaking creds. And we just use variables for our username and passwords. So, time for a demo. Gotta figure out what thing I'm sharing. Just gotta make sure I'm sharing the right screen. All right, so this is our demo file. If you look around, you'll see that we have our provider block for Openstack right here. Our project is my personal project. Here's our variable declarations for our username and our passwords. And then here is our data references to external resource types that we need to have to build our test server here. So this data block right here is our external network. It's what network we're going to attach our device to. And then we've got our flavor, which is just medium general. And then we've got our image that we're going to use. And then now we have a resource block, which we're going to use to create a new Ubuntu desktop. So this is our Terraform. Here is our providers file. The secrets.auto.tfvars has my username and my password in it. And we generally have a git ignore that prevents this file from getting pushed to the stack, getting pushed to the GitLab. And we can also use it to do fun things like set DNS records and have other variables that we don't want pushed. Then this right here is our cloud init file, and I'm not really going to talk about it, but cloud init is great. We reference that down here in our user data. So now, for the fun part of the demo, we're going to run the Terraform. So right here, Terraform show. You run Terraform show to show your current configuration. The output is blank because we have nothing. And now we do Terraform. We do Terraform plan. It will build a plan that will be run when we do Terraform apply. So looking at all of this, it's going to create our test server with all of these specific attributes. And then to actually run it, we do Terraform apply. So then we approve of the change. It takes just a moment to run. Just a moment. Did someone curse the demo gods? Because this was working like 20 minutes ago. Yes. Oh no, not another DDoS. DDoS does go great. Okay, anybody have any questions on stuff I've talked about so far? No questions. Cloud init. What can you do with it? That is the question. Let me pull up the cloud init real quick. So this is our basic cloud init that we use for competitions. This is actually one that I ripped from IRSEC. And cloud init is a nice tool. You can specify users. You can specify commands to run, like things to update, like on boot, so that like when your box is provisioned, it has all of these settings already applied. So this cloud init that we have right here creates a white team user, and then it creates. Oh, this is a hash. It's a make password hash of the password, which I'm fairly positive is don't fall in a well. And then it adds our white team user to the sudo group, gives it a default shell, sets the password. Oh, sorry, this is the SSH key that we add to the user. Then we have our password. We gotta set it up. We can change the password, set the time zone. Then we do a package update and upgrade. And then here we have a couple of commands that we can run. So you can do a lot of stuff. And what we really use Cloud Init for is to configure the boxes so that we can run Ansible on them and make that whole process a lot easier. So coming back to our Terraform apply, things finished. So now if we run Terraform show again, we can see that we have all of these resources. And now for the second part of the demo, we're going to pull up Openstack. Hit the what? Nice.
Excellent.
Right, so looking at the stack, and this is my project, we can see our instance, test server 1 right here. Then we can come look at it. We see that we have our default security groups. We have our testnet IP address. We have our image right there. And then if we go to console, we've got our Ubuntu desktop when it loads. If it loads. Boom. You guys don't know what I just did, but I typed like a 20-character password correctly, and I made the password, and it was a terrible password because it had weird capitalizations and weird numbers and like way too many underscores. But it worked, so I'm giving myself a pat on the back for that one. But yeah, this is what our small block of Terraform did. It created this box right here, which is cool. So this demo was successful. All right, we're gonna go back to the presentation now. Cool. So running our Terraform, as we just saw, we start, I did not do Terraform init, but Terraform init, basically you just initialize the directory that you're working in so that it can be configured to run commands, like run Terraform commands. Init specifically will create the backend, and it'll set up any remote state operations that you're going to have. At the moment, we don't have any remote state operations, so there's nothing to do. And then we run Terraform plan, and we can use the tac out flag in a file path to specify where that plan should go if we want to view it after we've run Terraform plan. Then we run Terraform apply, and we can either specify approval just using the tac auto approve flag, or we can apply we can give it approval by typing yes into the approval box at the end of the command. And then a really cool feature of Terraform is Terraform workspaces, which enables you to separate the state and have multiple copies of the same infrastructure. And we leverage this to deploy our competitions. When you have 16 teams that all have the same thing, and you try to run the same code 16 times, it's not going to work too well because you already have the state built. So we use workspaces to separate the state so that we can have multiple copies of the same infrastructure, just in different projects. Speaking of Terraform State, Terraform will keep a local copy of all of the resources that it builds, and when you run a Terraform apply, it'll take the current configuration that you have in the state file, compare it to what you have changed or you have written in the Terraform apply, and then it'll update the state to match what you applied or what you want to apply. However, if you lose that state, it's pretty much the end of the road, because It's very hard to get another copy of the state, and if we delete the state, then all resources on the stack get orphaned from our Terraform, and doing Terraform destroy will do nothing because it has nothing to delete from the state, and it's just a big mess overall. So when you work with Terraform, make sure you keep your state very safe. There are ways to do backups and to have like a remote copy of the state configured to another place. However, we have not gotten that working quite yet, and it's rather finicky, and GitLab doesn't like to do workplaces. So it's very sad. Now we're going to start looking at how we use Terraform for our competitions, like how we kind of build our Terraform to deploy all of our competitions. So at the moment, at least the Terraform that I'm going to show you all is the IRSEC Terraform, and we'll go over like the configuration that we had for that. It's since been updated for ISGS, but that is currently not in a displayable manner. So we'll go over the IRSEC Terraform instead. We have three big projects. We have three big directories. We have a projects directory, we have a management directory, and we have a teams directory. Within the projects directory, we will create all of the projects, and we'll define all of the quotas for each of the projects. So quotas are basically just things like how much RAM, how much block storage, how many volumes, how many networks, how many IP addresses, all of that stuff we define as a quota. And we will create 16 team projects for each of the 15 teams in one of the test teams. And then we will create one management project and one cloud project. The way that things get permissioned within Openstack, teams will get access to see their team project, but not their cloud project. And that's how we create the cloud infrastructure. So like from a black team perspective, like we can have console access to all of the hosts because we can see into the cloud project and get console access that way. However, to create the cloud environment for the competitors, we disable that permission, and that way they have to use the promoting protocol to access the cloud resources, like the cloud network during the competition. We will also create users and permission the projects appropriately. So if you guys have blue teamed on the Openstack before, you've probably seen how your entire team got one account to log in as, and if one person changed the password, everybody got locked out. That's because we give each team one set of credentials and one username. And then we have a black team group on the stack that we add all the current black teamers to, and then that black team group gets added as an admin to all the projects. We also will create the security groups, and as I mentioned earlier, security groups are like basically the firewall rules, where we can allow inbound or outbound traffic to specific ports from specific IP ranges, and it's how we enable network connectivity to all of the hosts. So within the projects directory, we have a couple of files. We have the projects file, which builds out the projects. Then we have our groups file, which permissions all of the projects. We have our set groups, which defines all of the security groups and the rules. Then we have our users file, which will add all of the users to the stack. And then we have two supporting files, variables, and project auto.tfrs, which variables will specify out all of the variables, and then this project vars will specify things that get updated regularly, like the competition name and the domain for the competition and stuff like that. Within the management directory, we do a couple of cool things. We build out our management servers. So we have two Windows DNS servers. We have a Chocolatey server. We have our deploy host, and we prevent Braden from running Ansible 2 on the deploy host. We have our store, and we have our scoring engine, and we have our beat. We have a VPN. There's basic stuff, basic infrastructure to make the competition work. And then we build out a couple of networks, namely the management network, the alternate network, the VPN network. The VPN obviously connects to the VPN network, and some of the other hosts connect to the alternate network. And then we apply public IPs to things that need to have public DNS, like our deploy host, our scoring host, our beat, our VPN, stuff like that. Within the directory. This is the structure. We have our main.tf variable. Sorry, we have our main.tf file, and this is where a lot of like the main configuration goes. So this is like the main files where we will define all of our servers, and we'll have a variables file to help support that. And then we have a subfolder called comp management that takes in a lot of the variables that we define within the main and then converts them into actual images and kind of abstract some of the nitty-gritty details into this subfolder to make everything more readable. The teams are structured in a very similar way. We have team LAN, we have our cloud servers. It looks a lot like management, except we're doing this with the team networks. We have two modules, the team LAN and then team cloud. And then, yeah, looks pretty much the same as the management project. And then we have our files directory, which we put all of our cloud init in, and then that's pretty much all of it. So at this point, we're going to look into the IRSEC Terraform, and we'll get into some of like the specific layouts of all of it. Any questions while I pull up Terraform? We did not need to sacrifice to the demo gods because it did work. So I just gotta get the right file open. All right. So here we are within the IRSEC Terraform. So we'll start with projects, and we'll go so this is our projects directory in our projects Terraform file. So here we can see that we specify a resource. We have our management project, and we give it a description, and then we give it a variable competition name, which actually will go. So we give it a name, and we give it tags, and we use tags on pretty much everything to help us find the resources from the Openstack CLI in case things get orphaned, and just kind of help hunt them down when things go wrong. So we have our networking quota, where we specify the amount of floating IPs, the amount of networks, subnets, ports, routers, all this other stuff. We have our compute quota, where we specify RAM, quota, cores, and a number of instances. We've got block storage, and it's just a lot of specific pieces of data that we need to specify to make sure we have enough resources available to deploy our infrastructure. And we do the same thing with the cloud project. You'll see everything's pretty much the same. Well, it's not the same like quantity-wise, but it has the same structure. And then we do the same thing with the team projects, except this time we use a variable to increment the name so that we have one project per team. So you'll see we have like the way that the name of the project would be ISTS team 1 or team 10 or whatever this variable gets evaluated to be as it applies the changes. And then we have more quotas for networking and compute and block storage. That's how we kind of build the projects. Then looking at the groups, this is actually pretty simple. We just specify a couple of groups on the stack. Then we add them to all of the projects to make sure that everybody has access to the projects appropriately. Then set groups is where we define our security groups for all of the pieces of competition. So the way that each of the set groups works is we we will create a sec group, and then we would make a rule to apply to that security group. So looking at our deploy security group, we have a tenant, which is just our project. So it's where we're going to build the rule. And then we have the rule that we're going to apply to the security group. So we're going to loop through this variable called deploy ports, which we'll go check out in a moment. But then we're going to add like these specifics to all of them. And then for the variable, we come over to our variables file, and then we find deploy ports, and we will iterate through this map to add all of those rules to our deploy host. That's kind of how projects works. We're now going to move to management. So from the top here, we have our provider block, which is cool. Then we have our management project block as a data resource. We have our RT external network. And then right here, we have all of our images defined. So it's really just a Windows server and then a Ubuntu cloud image. And then from there, we specify flavors because we have, I guess, 5 different flavors that we needed for management. And then here, we build our core router for the competition, which everything will basically connect to. And then we get into our module networks. So within this block, we'll come back to all of this stuff later, but we specify a VPN, and this is all information that gets passed to the VPN module, well, I guess the VPN block within the networks, and then we create a map of hosts. And so this hosts map contains all of the hosts that we're going to put in the management project. So we have DNS1, DNS2, we have our deploy host, we have our chocolatey host, we have scoring, our beat, our store, and our logging host. And within each of these host declarations, we give it a reference to the image, a reference to the flavor, we give it a block size, we give it an IP address, a network, and a security group. Then we come over here to this instances file within the module. And then we can see that we have our resource declaration where we take all of the values from that map of hosts and we pass it into this block, and they all get made here. So all the things that we just specified within the hosts map gets turned into an actual instance through this instances file. So as you can see, we have our block device, we have our network, we have our user data, and then we also have a block for our VPN because the VPN is special. But you can see that we have references to the name using the key, which is just the key value, which is the key part of the key value pair of the map. And then we have our flavor, we have our tags, we have our security groups, and then yeah, this is pretty much how we build our Terraform. So, any questions? Okay. We also have our networks, which is where we build all of our networks. So we see we have an alternate router. We've got our management router up here, or management network up here. Security groups is just a local reference of all the security groups within the module. So that way, when we go to build all of our instances in our instances file, we just reference like this local security groups set of information. Yes. I spent about an hour in the club room just like reading individual files, trying to guess like which one I have to modify first. And after like reading through all of them, I found main.tf, and then I read the name and was like, oh, this name is a pretty good hint. And then within the main file, I saw all of the hosts, and it had all of like the competition-specific hosts that we were going to deploy for ISTS last year. And after finding this, I kind of started to understand how things were working. And then it was a lot of modifications to this, to make sure that things were going to overlap with the ISTS projects that were happening. And then it was a lot of Terraform apply, read the error, Google the error, make a modification, ask Dan about what was happening, Google it again, and then try it again. And then I did get into some of the Terraform docs towards the end of that process, which I do have a slide about at the end. But it was a lot of trial and error for me, which is why we're building the wiki, because I spent like 3 weeks like just doing Terraform, and nobody has time to do that anymore. So wiki. Yeah. That was, I mean, we can walk through the teams. Pretty much the same beat. Like we have our router block, which is like our VPN, but it's for our router. We have our hosts map, which defines all the hosts that we're going to use during a competition. And it's pretty simple. We have, yeah. I'm just kind of repeating myself at this point. So are there any other questions? All right, I'm going to swap back to my presentation. So some of the stuff that we do using Bash to deploy our competitions. We use a for loop to iterate through workspaces and to run the Terraform using a team number variable. And then we can destroy instances by using the tac target with the Terraform destroy command. And yeah, in the future we'll be looking at some other stuff involving remote workspaces, but yeah. Some other future projects that we have includes better documentation and better readmes. I would say that a lot of the code is really well documented at the moment because I went through and did it. When the first time I was doing it, I was documenting everything I was writing, doing and running into. A future project on the more technical side is writing a linter for the Terraform Openstack. There are some linters, like open source linters for like the Amazon, AWS, Terraform provider modules, and having a linter for Openstack would be fantastic. So I might be looking into writing that, but this would be a large project. Terraform Playground is basically like kind of ties into the linter, but it's just creating like a website or something where people can go in and like play around with creating Terraform and then running it locally, and it's kind of like how you can run. If you go look at like the Go docs, like the tutorials, like you can run Go code within the browser, and you can kind of learn how to do it that way. Similar idea, but for Terraform. And then creating some small Terraform templates for personal projects so that everybody can utilize the stack for their personal research projects or just for fun and whatnot. And then a long-term project would be creating backups of our OpenStack Terraform and porting it to AWS or GCP in case something goes horribly wrong with the OpenStack instance and we need to host a competition on another set of resources. Any more questions? Seeing none. Some other resources. The OpenStack Terraform docs are really good, and there's documentation on every single resource that you could use and all of the options to configure them within that resource block. The Terraform.io docs are also really good. And then looking at previous competitions Terraform. If you look at like IRSEC from 2 years ago, all the Terraform is in one file, and now it's in multiple directories, and the file is in 1,000 lines long, which is really cool. And in the future, it'll be well documented and also have a wiki. Any questions? Did you all learn something about Terraform today? Great. That's the end of my presentation.